Hello everyone, welcome to Software Design with Tuhin. This is third episode of Google ADK series, and today we'll be discussing what are the different types of agent and what are the building blocks of an agent. So before going into the third part of this series, we'll quickly recap from the episode 2. In the episode 2, we discussed about integrating light LLM in order to call models other than Gemini. So Gemini is by default integrated with Agent Development Kit, as Agent Development Kit is by Google, but there can be separate need for integrating other agents like OpenAI, Claude, etc. So there we use Light LLM. So Light LLM not only provides a very nice interface for integrating with other agents, but it also provides a lot of additional features like tracking cost, making observability. It also provides nice gateway where we can do authentication, rate limiting, etc. Finally, we have seen a very nice demo how to integrate Light LLM into ADK agents. So if you have not seen that video, please take time to see that video. It is definitely help you to understand how to integrate other agents other than Gemini in ADK. Now, coming back to the current episode, where we'll be discussing what are the different types of ADK agents, what are the different agent properties, like what are the different building blocks of the ADK agent, and building an agent with the different properties. And finally, we'll be seeing a demo and we'll run that particular agent with all the properties that we have discussed in the current episode. So this episode is going to be lengthy, but you will be learning a lot of interesting topics that is not covered in any other videos in YouTube. So let's see what are the different types of ADK agents. So there are mainly three types of ADK agents, like LLM based agent. We call it LLM agent. Next one is the workflow agent. Workflow agent can be three different types. One is sequential agent, parallel agent, and loop agent. And then if you have very specific needs which cannot be covered by the LLM based agent or workflow agent, then we need to write a very custom logic and we call it a custom agent. So all of these kind of agents are extended from the base agent. Now let's know what is LLM agent. Now LLM agent, or in ADK perspective simply mentioned as the agent, is the thinking part of the application. It leverages the power of the large language model to understand natural language, reason, plan, generate responses, and dynamically decide how to process or which tool to use. Now we have not discussed the tool yet, but in the next few episodes we will be using the tools extensively, and we'll also know what are the different types of tools are supported in ADK. Now in workflow agent, this is a kind of specific type of agents when you need multiple agents to collaborate. Then we need the workflow agent. Now you want to perform a specific task in a deterministic fashion, means the first agent will be executed and then you want the second agent to be executed and then you want third agent to be executed. This particular flow of agents, you want it to be a deterministic manner, then we use workflow agent. The flowing the data from one agent to another is completely deterministic, though the output of the individual agent is not deterministic, because that cannot be deterministic because the LLM output itself is not deterministic, because for the same input the LLM provides the different outputs. But when you want control flow to be deterministic, then we use workflow agent. Now workflow agent can be three types: sequential, parallel, or loop. We will be knowing each of these agent in the later section of this series. Now finally, the custom agent. The custom agent is extended by the base agent. This agent allows you to implement the unique operational logic and specific control flows or specialized integrations which cannot be covered by the LLM agent or by the workflow agents. Now let's quickly see how to decide what is the right agent type for your need. If your primary functions is reasoning or generation or tool usage, then we'll be using LLM agent. If you need a series of different agents and you want that control flow between these agents are deterministic, then we'll use workflow agent. Now if you have a very specific need that cannot be covered or very custom logic need to be done, then we'll be using the custom agent by extending the base agent. Now core engine for the LLM agent is the large language model, and for the workflow agent it is a predefined logic, sequence, parallel, or loop, and custom agent, it's a custom code. Now in terms of determinism, LLM agents are non-deterministic. As you know, you give the input, the outputs are decided by the LLMs, and LLM is non-deterministic in nature. So for the same input, the outputs can be different. Now for the workflow agent, it is deterministic. The flow of the execution of the agents are deterministic. So it can be sequential, parallel, or loop. In case of custom agent, it can be either of it, based on the how we implemented the custom logic inside the custom agent. The primary use cases are language tasks or dynamic decisions, and in case of workflow agent, we want some structured processes or orchestration of the agents, and in custom agents, it's the very tailored or unique kind of requirements or specific workflows. Now few agent properties that are quite frequently used, that are name, that is the name of the agent we provide, And description, it is optional, but it is quite useful to understand what is the purpose of that particular agent. And it is recommended for the multi-agent setups like sequential, parallel, or the loop agents, because there are multiple agents are there, and if you give the descriptions, you'll get to know quite easily what is the purpose of that particular agent. Now, the model, it is anyway required for the LLM agent, where we need to specify the which particular model will be used. By default, the Gemini models are used, but we can integrate multiple different other types of models as well. So that is quite well supported. I have shown you in the last episode with the light LLM, we can quite easily integrate with other models as well other than Gemini. Now, instruction is the place where we give the instructions of the LLM agent, what that particular agent is supposed to do. There are quite a specific different ways to write the instructions. It is mostly related to the prompt engineering, and there are some kind of helpful guides available in the ADK agent sites. I'll be providing the link in the description. Last comes the tools. Tools, when you extend the functionalities or you want to perform a specific deterministic action, then we use tools. Now, tools can be a simple Python function, or it can be a API call, it can be database operations, or it can be a very specific kind of business logic. When you want agent to perform a specific kind of actions, then we use tools. We will discuss the tool or implement the tool in this current episode, but in the later section of this series, we will be describing and showing that how different types of tools can be used in ADK. Now let's see how normal agent with the basic capability looks like, with the basic parameters. We create an agent like LLM agent, and model is specified Gemini 2.0 Flash, and name we have given is the capital agent, and description that we discussed, that is, it is optional, but it's always good to give. So what it does is like answers users questions about the capital city of a given country, and we have given instructions that you are an agent, and now we are telling that you use that particular tool, that get capital city. Now, what is the get capital city? It's nothing but a simple Python function which takes an input of a country, and it also produces an output string, and we have given a set of kind of dictionary of country versus capitals, and it responds with the capital for a given country. Or if it does not find that country, then it says I don't know the capital of the country. Now, this can very well be replaced by API call or the database lookup as well. Now let's see some advanced properties that are supported in a LLM agent or PyAgent. First is generating content config. So you can adjust how the underlying LLM generates responses using generate content config. Pass an instance of Google Geni types generate content config to control parameters like temperature, max output tokens, top P, top K, and safety settings. Now let's see how does it look. So here we used a particular agent. So other parameters that we have described in the previous section that are anyway required, like name, descriptions, model, tools, instructions, etc. Additionally, we'll be passing one more parameter called generate content config, and here takes again few parameters like temperature. It closer to 0 means more deterministic, and closer to 1 means more non-deterministic output. The maximum output tokens is limited to 250, but we need to use cautiously. So here we are limiting that particular LLM model that you use within that particular token limit. So some cases might require more number of tokens to generate a flexible output. And safety settings. So safety settings are nothing but a kind of guardrail. So where we are instructing the agent what kind of things it need to filter out while generating the responses. Next important property, but it is an advanced property, will be using the input schema, and output key. Now for scenarios requiring structured data exchange with an LLM agent, the ADK provides mechanism to define expected input and desired output formats using schema definitions. Now input schema, it is definitely optional because it requires a specific format the input to be provided, but as LLM or LLM based agents are mostly takes input from the user, so instructing the user to provide the input in a specific format or formatting the user given input to a specific format sometimes might not be possible or not feasible, so it is very less used. Now is the output schema. Output schema is very frequently used because often the output that is generated by the agent that needs to be sent to another agent or needs to be processed by something, then we want the agent output in a specific format where we use the output schema. We'll be seeing quickly how we can generate a specific format out. Now next important thing is the output key. If we want the output to be stored in a specific key in the session variable, then we use that output key and there we provide that particular key name. This name will be used inside the session to store the output. Why do we need that? It can be used by other agents for the further processing. So mostly used for the kind of sequential agent or parallel agents or kind of workflow agents Let's see how it is used. So first we have defined a class called capital output. So what it does is like property is capital is a type of string, and we have given a descriptions the capital of the country. Need to use some required properties like name, model, description, instructions, tool, etc. Now we are providing one additional outputs property called output schema, and here we are providing the capital out, and which is nothing but this class. So we are instructing the agent that you provide that particular output in a specified format, and output key, whatever the output is generated, that will be stored inside the found capital, and it will get stored in the session with that key. In this kind of scenarios, it is not very useful to tools for that particular purpose. Now next important advanced property is the built-in planner or planner. Planner can be two types. One is built-in planner and plan react planner. So built-in planner is the which leverages the model's built-in planning capabilities like Gemini's thinking feature. Plan react planner, this planner instructs the model to follow a specified structure in its output. First create a plan, then execute actions and provide reasoning for its steps. It's particularly useful for models that don't have built-in thinking capability. For the built-in planner, we use this kind of format, like in the built-in planner, thinking config, type thinking config, include thoughts true, and thinking budget is 1024, that is maximum 1024 tokens can be used. And in case of plan react planner, so we can simply invoke that and with some additional parameters, and we can anyway use the tools here. So last important property that we'll be discussing is the include content. So what is the include content? So if we want to add the historical conversation in the current invocations of the LLM, then we use this particular property. We pass the default. This means the agent receives the relevant conversational history, and if it is none, the agent receives no prior contents. It operates based on solely on its current instructions of the any input provided in the current turn. So this works like that. In case of stateless agent, we provide the LLM agent and include contents none, means it will not include any historical conversations while invoking the LLM. Now we'll be quickly seeing the demo with all the features or all the properties that we have explained. So we have created a class called capital output. So here we have used a property called capital, which is a type string. So this particular class will be used for the output schema. And we have also created a Python function called get capital city, which takes country as an input and produces the capital as an output. And we have given a dictionary of few country and their capitals. If country is not found, then it says, oh yeah, I don't know the capital of this given country. Now let's see what are the different properties that we have used. Root agent is the LLM agent as we discussed earlier. So this is the root agent, and name of the particular agent, that is the LLM agent config demo agent, should be same as the directory name. Otherwise it will not be able to load that particular agent. Description, short descriptions, the answers user question about the capital city of the given country. And I have given an instruction called you are an agent that provides the capital city of the country. Tools, I have used this particular method or function, and this can quite easily replaced by one API call or database calls. Generate content config, this is on advanced property where we are giving the temperature 0.2, means we are expecting a more deterministic output, and maximum output tokens allowed is 250. That is the maximum number of tokens that will be used in the for generating the output. Now the safety settings is nothing but a guardrail where we are asking that kind of content should be filtered out. In the output schema, we are invoking this class. We are instructing that agent that while generating the output, you use that particular schema. We discussed earlier that this kind of output schema is quite useful when you use the workflow agent. So this output of the particular one agent will be used in the next agent, and here output key is the found capital. So whatever the output is being generated, that will be stored in a found capital key inside session. And the planner, we are using the built-in planner, which will have some thinking capability and includes thoughts true, and thinking budget is maximum 1024. Next is the include content none, means we are not using historical conversational data while sending the data to the LLM. Now it's time to see it in demo. Now in order to run that particular agent, what we need to do is like run ADK web. But before that, I just want to show you what are the packages that are used for this purpose. So we used python.env and then Google ADK, and these two are sufficient for running that current project. But I have used few more packages because it's a common pyproject.uml file for the all projects that I've used, that I'll be anyway describing later. Okay, and I used UV for the dependency management. You can check my UV video if you want to learn quickly how to use UV for dependency management, and definitely check the first video in this series to setting up ADK. Let's go to the running. In order to run a ADK project, we need to run ADK wave. Now once we run it, it starts running in localhost port number 8000. Now opens like this, and now we need to select the agent that we just built, that is LLM agent config demo, and here is the demo. Now I will ask what is the capital of India. Now we'll see few important observations here, like it has a thought settings that it thought that okay, here is what I'm thinking. The user's question is straightforward. They want to know the capital of India. Since I have access to the get capital city tool, that seems like a perfect solution. I just need to feed the country argument, and in this case it's clearly India. Once I have the capital city, so you can see it here how it is working. So it is invoking that particular tool, that is the get capital city. It found the get capital city here. Next, another thought is like answering the user's question. The user wants to know the capital of India. That's straightforward enough. If the I'll use the get capital city tool. This is the tool, get capital city tool, feeding India as the country, and let's see what is the response. So set model response, and now here comes the output. Now output is not a natural language text or simple text, but rather a very structured output. What we instructed the particular agent that to store the output in a specific format, to generate the output in a specific format. So also we have stored that particular output inside a particular key, that, and here you can see the how the trace and how the executions or call got executed, different steps got executed. So first is call agent, then execute tool, then call LLM, then execute tools. All the sequence of executions you can check it here, and these are the different events that happen for this. So this you have understood what all are the required properties of our agent. Not only the required properties, but some very advanced properties than for an ADK agent, and which might be useful for develop advanced ADK agent. If you liked my video, then please like, comment, share and subscribe. Thank you for watching.